Hello. In this video, we will be discussing how to analyze data in order to interpret or explain phenomena or things that take place around us. So first, what is data? It's a word we use a lot in science, but what do we actually mean when we say it? So data is simply information. Oftentimes, and what we're looking at today, data is in the numerical format. And data is information that's collected through some form of observation. So, looking at something and taking down measurements or some form of observation. So, why do we talk about data so much in science? What is it used for? So, in science, data is how we are able to understand, explain, and prove the cause of many different phenomena or things that happen in our universe around us. Data also allows us to look at multiple variables and explain the relationship between them. So much of what we do in science, if not all, is data driven. In order to prove or truly understand why something is taking place, we need to analyze, interpret, and present the data to explain. Today, we'll be looking at three specific ways that we represent data visually. The first is data tables. We use these all the time. We know that this is a way of simply organizing the numerical data in a way that's easy and clear to read. The second visual display of data that we'll be looking at today is a graph. Specifically, this is called a scatter plot. Finally, we'll also be looking at bar charts. You may not have seen those much in this class, so we'll look at them today, but you may have seen them elsewhere. So we know that data is simply information in the form of numbers. So one very important skill that we do in science is organizing and displaying data visually. So first, let's look at how we analyze a data table. So as a reminder from Unit 0, we know that in a data table, we have two variables. We have our independent variable, which is found on the left-hand side. Remember that your independent variable is the variable that is manipulated or changed on purpose in the experiment. The dependent variable, which is found on the right-hand side of the data table, is the variable that is measured at the end of the experimentation in order to determine the change that took place based on the manipulation of the independent variable. So what we want to do as we're analyzing any data, including a data table, is think about as that independent variable changes or is manipulated, what is happening or what is the effect on the dependent variable. Now, let's look at a very applicable example to what we're investigating in our project, the data table from the Socorro Dove. So as I analyze this information, I can see that my data table includes on the left-hand column my year and on the right-hand column the Socorro Dove population. This tells me that the year is, of course, my independent variable. I also can think that the Socorro Dove population changes based on the year. The year does not change based on the Socorro Dove population. That confirms that year is my independent variable. So we can see that my year starts at 1924 and ends at 2004. So as I said, we want to think, what's happening to that independent variable? First, we can see that it is increasing. We then look over at my Socorro Dove population, and I can see very clearly that over time, it's gone from 500 to 0. So I can see that that dependent variable is actually decreasing. So a very clear way to explain what I can see is taking place in this data table is that as my year or my independent variable increases, the Socorro Dove population decreases. So now let's take a look at how we would analyze a graph or a scatter plot. So first, let's look at the components of a graph. As you know from math class, on any graph, we have an x-axis and a y-axis. On a graph, we know that our dependent variable belongs on the y-axis or the vertical axis. Our independent variable is found on the x-axis or the horizontal axis. Just like we did when analyzing the data table, in order to analyze a graph, we want to consider as that independent variable, again found on the x-axis, changes, what happens to that dependent variable or the variable I find on the y-axis. If I look at my data points and my line of best fit here, I can see that as temperature is increasing from about 12 all the way up to almost 26, I can also see that the sales are increasing from down here in the 200 range all the way up to around 800 or more. Is as temperature increases, sales also increase. Once again, let's look at an example of analyzing a graph, but in the case of our Socorro dove population. If I look at my graph here, I can see that again on my x-axis is my independent variable. So I know again, just like my previous example, that year is the independent variable. I then see on my y-axis Socorro dove population. So now if we look at our trend line here and our data points, we can see that year is going from 1920 again all the way down to about 2004. So we know that year is increasing. Now let's look at what's happening to the Socorro dove population. We can see that my data points are going from all the way up here at 500 slowly and then more drastically down all the way to 0. So how could we say this if we wanted to describe what was taking place or what was the relationship between these variables? We would say that as year increases, the Socorro dove population decreases. Finally, let's look at bar chart. So in a bar chart, just like we saw in our graph, we have two axes. Down at the bottom, just like on our graph, we have our independent variable. In this case, you will see just the same. My independent variable is year. On our y-axis, we have our dependent variable. In this case, it also happens to be sales. Now in a bar chart, we have just that, bars. Generally, or oftentimes they are color-coded. So in this case, we can see that the blue bars represent fruit, whereas the green bars represent vegetables. And you will also see that when the bar is drawn, it lines up to whatever value it's meant to represent on that y-axis or of that dependent variable. So now let's see, how would I analyze what's going on in this bar chart? So I can see that we have 3 years that we have data on. So we have 2011, 2012, and 2013. I can see that in 2011 we had somewhere in the range of maybe 750 or so fruit sold, and about maybe 575 or so vegetables sold. We can see that as we move to 2012, it's very, very slight, but we can see a very small increase in both the sales of fruits and vegetables. And then finally in 2013, again, it is very, very faint, but we can see another small bit of growth in the sales of fruit and vegetable. So again, we have an example where as year or independent variable increases, the sales of both fruit and vegetables also increase. Finally, let's look at our bar chart here in the example of our Socorro dove. So we can see on my x-axis, we have the same independent variable, of course, because we're looking at the same example, which is year. We can see that it goes all the way from 1924 down to 2004. Same example, so same dependent variable here, which is Socorro dove population. Now let's take a look at what is taking place over time, over a year, with the dove population. So we can see again that we're going from 1924 to 2004, so we know that year is increasing. So as that deep independent variable or year increases, what can we see is taking place to the dove population? We can see that it's starting up here at this first bar at right around 500 and is incrementally and then rapidly decreasing all the way down to 2004, where we can see there is no bar representing 0 Socorro doves remaining. So again, we can say that as year increases, the Socorro dove population decreases.